afternoon, everybody. Some of you I can see, and others, it's very bright up here. So my name, as Jeremy said, is Lauren Holloway. I'm with the PCI Security Standards Council. Today, along with Peter O'Sullivan from Blackfoot Cybersecurity, we're going to explore the implications of infrastructure as code, or IAC, within the context of PCI DSS.
Hello everyone, I'm Peter O'Sullivan. I'm a QSA and 3DS QSA with Blackfoot. I'll be focusing on how IAC can be implemented in real-world scenarios, along with the PCI DSS acting as a security control, and provide practical approaches for assessors when validating IAC.
So, as hopefully many of you know, PCI DSS sets the requirements that are needed to protect account data within environments that store, process, or transmit that account data, or in environments that can impact the security of that data.
Whereas IAC is using tools to manage cloud-based infrastructure and computing components using machine-readable configuration, otherwise IAC, that applies to one or more virtual devices or services simultaneously. And where cloud-based infrastructure is in scope for DSS, requirements that are using IAC will integrate with PCI DSS really well to help organizations secure their environments. By automating infrastructure management, it allows for that greater consistency and control, which aligns really well with DSS.
So this shows briefly the difference between traditional infrastructures and infrastructure as code infrastructures. Try saying that fast. With a traditional approach, you have hardware configurations that are updated manually at the console of each device, and they're applied to each device individually. So the person has to touch each device separately, and it's not scalable, and it's subject to errors and misconfigurations.
Conversely, IAC offers several distinct advantages. By using code and tools, you're managing the infrastructure by processing that machine-readable code. You create it once, you might modify and improve it, and it's then sustainable and can be used repeatedly. It's going to give you that consistency, that repeatability, and automation within your infrastructure management. Now, IAC documents illustrate how entities can streamline infrastructure management whilst enhancing security and compliance.
So here's a picture of what we just were talking about. You have an engineer, they're sitting at a terminal, and they are updating a single component at a time.
Whereas here, you've got the engineer preparing their separate IAC documents, or maybe single ones, and generally storing them within a distributed version control system, aka a repo, something like GitHub, GitLab, etc. There's going to be a processing mechanism, the engine, that's often connected to those repositories, which will process those documents to build out system components in the target environments, which has been defined within the documents. Often, you'll find parameters in there to facilitate scaling, alternate environments, or resizing those components as required. Example technologies for this might be something like Terraform, CloudFormation, and Salt.
So this shows the scope for traditional network architecture. You have a building, it has computer equipment in it, there's a firewall which controls access into the organization's cardholder data environment. And the gears or cogs that you see on this slide, you'll see also on several other slides as a reminder about all the processes that need to be in place to protect any of these kinds of environments. And then the orange border, of course, is the CDE and the connected to systems that are in scope for the organization's PCI DSS assessment. And this diagram shows the organization. They're still managing most of their computing devices in-house, but they also now have a cloud-based code repository. And in this diagram, you're able to see several engineers. They're working remotely. They have access into the organization's environment through the firewall, and they also have access to the cloud-based code repository. And all of this is in scope for this PCI DSS assessment. Endpoint considerations are really crucial in an IAC environment because you need to make sure every endpoint is secure so that you can prevent unauthorized access and modifications and potential breaches.
So it's particularly important that you're valid.
Go ahead. Go back, please.
So it's particularly important that scope validation is performed regularly to check that all your relevant components, people, processes, technologies are included continually within that scope. And ongoing processes help to maintain the integrity and security of that infrastructure. Now here, all the infrastructure has gone to the cloud, which is quite common these days in newer deployments. And most staff are going to be working remotely in some capacity. The organization's environment is entirely in the cloud, and there's likely something like a SaaS solution, which is hosting the repository. We have to remember that all of this remains in scope for the PCI DSS assessment.
And it's also important to remember the geography involved with this environment, because these cloud locations could be in different countries and be in different assessor regions. So these are the steps to IAC. As you'll see, they're very similar to the steps for a traditional network architecture. First thing you do, you have to set your configuration standards, and then you get management approval. You determine the network configuration and the architecture, and then you develop the code or the actual configuration script. You go through the organization's change management policies, including management approvals and testing, and lastly, you deploy code to that device into production.
Now, in your engineering and deployment phase, it's essential that you test the resulting system components, which have been generated by processing the actual document through the engine. Peer review in this scenario is probably not going to be enough for you. Remember, this isn't programming. You're not generating an application, so it's not enough. Make sure that moving to IAC doesn't actually dilute your change records, which can sometimes happen, because there's a habit when you do go into this model that your change records become quite thin, because there's no relevant documentary found in the actual change record. People don't put it in the actual IAC documents, and then you end up with not a lot of pertinent information in here of the engineers who put it together. Now, that's why it's essential that your updated mechanisms reflect this. But don't forget, benefits of IAC are that in the event of the undo, a requirement that you can go backwards, the previous versions in the repository will allow for very quick redeployment of your environment.
And this shows the change loop. So every time you make a change to infrastructure as code, you have to repeat these same steps again. You have to re-architect it, modify the existing code, go through the change management process again, including testing, and then redeploy it, just like you would for a traditional network.
There's nothing more I can add.
So, surprise, Peter, we have a little pop quiz here. We take advantage of our resident QSA. So we have an organization that's launching a new API. They're going to use this to transmit and process cardholder data. And this is their first time implementing infrastructure as code. And it's also their first time they've implemented an API for cardholder data processing. They already do securely handle cardholder data in other services, and they've undergone a recent PCI DSS assessment for those services, so we're not going to worry about those. We're going to focus this exercise on identifying the applicable PCI DSS requirements for this new API. And this analysis will cover both what it means to the infrastructure as code and also what it means to the CDE components that are built from this process. So, Peter, this is their first implementation of an IAC environment. Which are the relevant PCI DSS requirements?
So, thank you for that. I'm going to do it in 2 steps. I'm going to focus really high level as well, so don't lynch me if you think I've missed something. So introducing IAC is going to be procedurally changing, so you're hitting requirement 1 straight away. You're actually bringing in the network components for IAC itself, so system components for that, so you know you're going to have some requirement 2 changes. This is significant. You're bringing in all this extra component work and change of process, so definitely requirement 6, along with having to consider how you would adjust your CDE so that you're not fighting with permissions, so 7 and 8 as well. Those components creating IAC are actually themselves system components, so will need to be subjected to testing and logging. And so additionally, you've then made a change again, so you're looking at scope change as well. So your big aspect here, have we gone too far?
No, I think we're good.
We've gone.
Can you go back, please?
I think it's the presenter notes which need to go backwards.
No. That's it.
Stay there. No. The presenter next back again, please.
I think it's there.
No, it's not.
Oh yeah, back a couple more, sorry. On the notes.
One more, please.
There you go.
Perfect, thanks so much.
Sorry.
Okay. So let's go back to testing. So we've tested the components and we now need to change the scope. So 12.5 will definitely need to be adjusted by the fact that you're now processing things using IAC. Now also, if you've gone for a cloud-based repository, there's a good chance there you've now got a 12.8 consideration because you've got a new third-party service provider. Now, there's often a misconception that by bringing in IAC, you're going to reduce your assessment time. That needs to be just dealt with straight away. You've got brand new system components, brand new system processes which are running. So you're going to need to consider what additional assessment time you might need to have when using IAC within a deployment, and the guidance you might need to give to your clients when moving to IAC. So it's going to be quite the opposite. All this additional time is going to be required when you move forward in this way.
So let's focus on the relevant requirements to the CD components that have resulted now from this IAC document, and hopefully without any snafus.
So from this point onwards, it's a normal change activity that all of us would know how to deal with. So you're going to make a change to the network, requirement 1. You're bringing in a new API system component itself, requirement 2. If it's an API, it's going to be transmitting data in and out of untrusted networks, so requirement 4 is going to kick in. You've got a major development going on there, so requirement 6 needs to be thought about, and the changes. You've got to think about access to those system components, so 7 and 8. As you might expect, you're going to have to log what's going on within the API, requirement 10, and also test it, so requirement 11, and ultimately more scope change, so requirement 12 as well. Now the one thing here is that IAC's bringing in governance changes, so it's really important that when you do that, you do them in a way which actually makes them more and more robust as a control, which helps maintain your infrastructure in as much a secure way and compliant way with all the expected benefits that you'll get from introducing IAC. Now, another consideration here about this particular example is whether or not it will be partial assessment or full assessment, but that's absolutely stretching into the realms of compliance. Therefore, that's a discussion with your compliance accepting entity and not for here.
So it seems that the introduction of the infrastructure as code components have now been absorbed into the scope of the assessment, and going forward, these controls will be in place for any management using IAC.
Correct.
So Peter, is there anything else you'd consider for your clients when you're assessing such a situation? For instance, if the repository is cloud-based, you did mention you've got service provider component as well. So
yeah, so scope is a major consideration when you're, as you saw in the example, new system components are being introduced by virtue of the IAC technologies, and as well as anything else it's bringing online. So you would need to think about the repositories, automated systems, et cetera, et cetera. Access control measures will almost always be impacted by implementing IAC, because IAC's taking on the actions of the configuration which would normally be done by administrators. So you've got to make sure that you've addressed your access control considerations for the system components now being managed through IAC, because what you don't want to happen is for them to be fighting against each other, because then you'll end up losing integrity of which configuration is running and live at that time. Is it a hybrid of different things? And you need to try and avoid that. So any introduction of distributed version controls, repos, may also have an inadvertent impact upon scope, because cloud-based platforms which enable IAC are now service providers because they could affect the security of an environment. And also, by using a repo and having remote workers, their machines are now likely to be holding copies of whichever projects they've got access to. So their own machines might have a greater impact on scope, which you would need to think about. So do be mindful of those types of things and what it would mean to you when assessing the environment, because you'll need to consider the things like the system configuration standard changes, policies and procedures. But you know what? It's all very manageable by using the DSS as a framework.
So this also sounds like a significant change, and he did mention a significant change a couple times. So can you expand on that a little bit?
By all means. So in your traditional hardware-based deployment, there's lots of parties often involved in making change. Considerations like procuring the equipment. If finance know about it, it's going to be big. Racking it, deploying it, configuring it, and it's usually got standard operation procedures which go with that. Now with IAC, enabling new components could be a single document, and therefore it's essential that any change mechanism surrounding moving to IAC not only accounts for the tooling and the associated processes that go with it, but the mechanism must become much more sensitive to change because of the events that can happen by processing a single document. Those documents can all start to look very, very similar, and therefore cumulative effects that can result from multiple documents could be missed if you're not sensitive to the change. And it's also common to see those IAC documents becoming very lightweight. People cut corners, that's normal. They're not commenting, they're not writing document information in their change tickets because, again, we've talked about them becoming really thin. Those all contribute to that missing the idea that you've encountered a significant change within your CDE.
So what is the intersection between PCI DSS and infrastructure as code? Well, the same requirements that apply to traditional network configurations also apply to infrastructure as code. One must develop configuration standards to manage your infrastructure as code. You have to create policies and procedures related to how you're going to manage it, and you're going to implement the configuration settings. And the assessor then reviews all that.
So you might be thinking, well, where did IAC go out of the standard? It's mentioned once, actually, if you were to do a find and replace or something like that. Because ostensibly, IAC is a workflow technique, more of a mechanism, and that is for, to allow you to standardize your deployments and assurance of system configurations. And that's not mentioned in the DSS because it's not telling you how you must achieve it. So remember that the processes, applications, and services which are there to enable IAC are equally in scope and therefore need assessing as part of that process. More time.
So the governance controls are really essential for your IAC environments, and it helps ensure that your infrastructure remains secure. It's important to make sure you have relevant policies and procedures so that when you implement IAC, you do it correctly.
So your repos, your distributed version control systems, as they're officially called, they're almost always present within IAC. And what I'd suggest you do is try and make most use of the features within that system that you can to support the change mechanism. So you've got your access control systems, what permissions has somebody got into the repository itself. There's often workflows that can be attached to particular projects so that when steps happen, it will run checks and do things for you. And there's often other automation facilities that might be present so that it can contact, reach out, and populate that type of thing. All of these align really well with DSS requirements, though.
So change control is also a very important part of governance. In an IAC environment, the testing processes for your developed code versus the document changes must be different. Peer review of IAC documents can be performed, but you have to do second-tier testing of the developed resulting system component. You have to look at that system component.
So by introducing IAC, the processing steps that perform the administrative actions on the targets have been moved to the engine. So it's important that leaving out any administrative access from real people so that you don't get this recipe for disaster in the conflict. So equally, ensure that if you're going to move to IAC, you've got to make sure only the right people can access your repository and the documents in there, because that's really on par with admin rights and admin access, because that's what's going to affect the change in the end. So both will need careful consideration and planning and implementation in a manner that's compatible with PCI DSS requirements 7 and 8.
So to close out with some final considerations about infrastructure as code, cloud deployments using IAC really bring a lot of flexibility to different environments, and it helps you ensure that your configurations are consistent. Ensuring consistency isn't something you may have had the luxury of when you're dealing with expensive hardware. But make sure your configuration is targeting the right environment at the right time, and make sure you include all the relevant people, including engineers, network admins, operations, and security personnel.
So continuous security measures, those regular ASV scans, your pen tests, are key to maintaining any environment. So it's essential when you're using IAC techniques that the processes, whether manual or automated triggers, actually can still continue to happen when you're deploying PCI DSS requirements to either a new component or a modified component, because they still need to happen, so the triggers still need to be there. So change management plays a huge part in that, so make sure you upgrade your change management process when you bring IAC in to identify them.
And updating processes is really essential, as some historical guardrails that you may have had in place when you're using physical hardware are no longer there. If you execute an IAC document without appropriate governance, it could have significant impact on your infrastructure.
So as you do this transition into using IAC, ensure that moving to that workflow doesn't diminish any controls that you've previously established within a traditional environment.
Make sure you test your IAC deployments elsewhere before you put them into production, and review the actual system component that results. These system components are live at the point that that IAC document is processed, and if you haven't already tested it, you could put the production environment at risk in a split second. So infrastructure as code integrates management with automated, consistent, and scalable methods, and PCI DSS provides the controls to help you secure your infrastructure, whether it's cloud-based or hardware-based. PCI DSS controls apply to all environments.
So compliance with the DSS ensures that the security and integrity of the cardholder data is present. And it's important that anything you do with IAC does not erode or affect all that hard work you've already done. So the documented scoping information from PCI DSS Requirement 12.5 is an excellent and fantastic resource that can highlight the entity's understanding when they've implemented infrastructure as code with those corresponding processes that are affected. Requirement 6.5 and change processes must be much more sensitive to changes that can occur through the use of IAC, whether or not they end up being a regular change or a significant change. So moving to IAC, I'm going to say it again for you guys, rarely shortens assessment time. Ensure that where you've got increased amounts of IAC, you are reflecting this in the review time you'll need when performing your assessment. And finally, in using IAC for architecture and engineering purposes, ensure this isn't a red herring during the assessment for checking the actual system component directly. It's not programming to create an application. You can't just check the IAC document and expect that to be what's live. So this is bringing the system component live. You must continue to review the actual live system component.
So that's it. Thank you for your time today. If you have questions about PCI DSS, you can find me. I'll be here this afternoon and tomorrow. If you have questions about infrastructure as code, Peter will also be around. And you might be interested that this week we just published a new document from our special interest group. It's entitled PCI DSS Scoping and Segmentation Guidance for Modern Network Architectures. So you can find that in the guidance documents section of our document library. And you can also see a related post that we did in our PCI perspectives. So thank you.
Thank you.